Hello everyone, I hope you guys have been having a good summer. But year 13 is about to start, and trust me, that shit is not a joke. One of the first topics you'll encounter in year 13 chapter 1 is partial fractions alongside proof by contradiction, which we'll go over in another video. But for today, let's focus on partial fractions. They're actually really easy. All you need to remember is they just involve separating one big fraction into multiple fractions which are added or subtracted together. In year 7, you learn that to be able to add fractions, you need to have the same denominator and then you can add the numerators. We're just going to work backwards. This function here, 5x plus 3 over 2x minus 3 over x plus 2, can actually be represented as some sort of combination of fractions. So we have 5x plus 3 over 2x minus 3 over x plus 2. And essentially, we're saying this can be represented as a over 2x minus 3 plus b over x plus 2. And all we need to do is figure out what a and b are. To find out what a and b are, we have to add up the right hand side. So if I add up the right hand side using cross multiplication, which I'm sure you guys know by now, it's simply a lots of x plus 2 plus b lots of 2x minus 3. And again, the denominator is just the 2x minus 3 lots of x plus 2. And this is equal to my left hand side here, like we have here already. 5x plus 3 over 2x minus 3 lots of x plus 2. So since the denominators are the same, we don't really care about it. We can just cancel them out and we're left with the numerators. So the main function we're interested in is a lots of x plus 2 plus b lots of 2x minus 3 is equal to 5x plus 3. Why is that a bracket? Yeah. Now, to find out a and b, there's two ways. Either we can expand out the left side and combine coefficients such that the x terms must add up to 5 and the constants must add up to plus 3. Or we can use the cover-up method, and it's really easy. To do that, all you need to think about is what value of x should go into each of these terms to make them disappear. So let's start with the x plus 2. X plus 2 will disappear, or in other words, go to 0, if x plus 2 is 0, so x is minus 2. If x is minus 2 and we plug it in, minus 2 plus 2 is 0. And that leaves me with a lots of minus 2 plus 2 plus b lots of 2 lots of minus 2 minus 3 equals 5 lots of minus 2 plus 3. This disappears and we're left with b lots of minus 4 minus 3, which is minus 7, is equal to 5 lots of minus 2, which is minus 10, plus 3, which is, again, minus 7. So our b term is just 1, right? Because if we divide by minus 7, get b is equal to 1. Now, let's do the same to find our a term. If we have 2x minus 3 equals 0, right? 2x minus 3 equals 0 when x is 3 over 2. If x is 3 over 2, let's plug it in and see what happens. We are left with a lots of 3 over 2 plus 2 plus b lots of 2x 2 lots of 3 over 2 minus 2 is equal to 5 lots of 3 over 2 plus 3. Now, we picked the x term such that b disappears, so this disappears, right? And I'm left with a lots of 3 over 2 plus 2, which is just 7 over 4, equals 5 times 3 over 2, which is 15 over 2, plus 3. So in other words, it's 21 over 2. Oh, not 4, sorry. It is 7 over 2. So simplifying out by 7 over 2, divide by 7 over 2, I'm left with a is 3. So I figured out my a term is 3 and my b term is 1, which tells me that my entire big fraction of 5x plus 3 over 2x minus 3 lots of x plus 2 can be represented as 3 over 2x minus 3 plus 1 over x plus 2. And if you want to verify, you can expand out this term here and see that it matches up to the left hand side. All right, partial fractions are not bad. All you need to remember is use the cover-up method. I know most teachers insist on using the simultaneous method, but it can get quite complicated when you have qubits or even quartets or even higher power, right? So your best bet is to figure out what values of x make each term disappear. And from that, it's a piss take. All right, thank you guys for watching, and I'll see you in the next video. Thank you.